Hi, I wanted to show you some faces, edges, and vertices as I draw them out to give you a better visual of what these things are in our polygons. So when I talk about them, you'll know what I'm referring to. So I'm going to start by looking at two-dimensional figures, and then we'll transfer that information to look at three-dimensional figures. So the easiest two-dimensional figure is a square, and since it's 2D, it only has one face, okay? So we call this the face. If I want to find the vertices, that's where the edges come together. So my edge would be this here, that's 1, 2, 3, 4. So those are the segments that make up this particular polygon. So I can see I have 4 edges. And then I have 1, 2, 3, 4 vertices. And that's where our edges come together. I'm going to transfer this figure into a 3D figure. So if I start with a square, it's the same thing as this one. It has the 4 vertices, 4 edges, and 1 face. Once I turn this into a 3D figure, now this would be a base. These two are called my bases. They're congruent, which means they're exactly the same, and they're parallel to each other, which means they're on a different plane. This is in the front, this is in the back. Here's an example here of a cube. It's made up of a square. I have the front and the back. So this is the front and the back. If you notice, the vertices, there's 4 here. And since this is exactly the same as this front one, there's 1, 2, 3, 4 more vertices on the other base. The first base, the second base, 2 bases, and 8 vertices. Now I'm going to connect the back to the front with some edges. So remember on this one we have 4 edges. Well, since we have 2 exact squares, right now we have 8 edges. Watch how I connect this front to the back top. There's another edge, so that's my 9th edge. Here's my next edge, there's my 10th edge, that would be these two, connecting the front to the back. The bottom has to connect, so I had 10, this would be 11, and this would be 12. So once my square turns into a 3D cube, I now have 12 edges. And if you want to see that again, it's 1, 2, 3, 4 on the front, or it's called the base. The back, 5, 6, 7, 8, that's another base. This top connecting, and this one connecting, and the bottom, and the bottom. That gives us 12. It helps to count these in a methodical way, like have a system, front, back, okay? To do the faces, I like to do it methodically again. Front, back, top, bottom, side, side. So that's 1, 2, 3, 4, 5, 6. A cube has 6 faces. So again, 2D figure to 3D figure. The next figure I want to show you is a rectangular prism. So this one was called a cube. We're going to get into our rectangular prism by starting with a 2D rectangle. So a rectangle would look like this, and as you can see, it has just one face for now because it's a 2-dimensional. It has 1, 2, 3, 4 edges, and 1, 2, 3, 4 vertices. Okay, let's turn that into a 3-dimensional figure. Start with a rectangle. Now this is going to be called the base. A rectangular prism has 2 bases that are congruent and parallel to each other. So I could make this very long or I could make it short. I'm going to make it a little long by extending the back. This is the front, I'm making the back. I'm going to extend it a little bit away from this first one. So right now you can see the vertices. 1, 2, 3, 4, 5, 6, 7, 8. Okay. Again, I'm going to connect the top. That's going to give me 9, 10. Well, edges. Those are 10 edges now. I'm going to connect the bottom. 11, 12. So that's 12 edges, 8 vertices. And if we look at the face, I'm going to use a model for you. We have the front, the back, the top, the bottom, the side, and the side. To get the perspective on a piece of paper that's a flat surface, you can look at it as front, back, top, bottom, side, side. All right, then the next one I wanted to show you is a triangular prism. We can see it's got 3 vertices, 3 edges, and it's 2D, so it's just one face. I am going to turn this into a 3-dimensional figure. Right now I have my 3 vertices. I'm going to make this shape look like this model. So you can see the front triangle, that's called the base. The back is congruent, exactly the same, and parallel. They lie on different planes. So I'll put this one way back here. So right now I have 1, 2, 3, 4, 5, 6 vertices. Those won't change. I have 1, 2, 3, 4, 5, 6 edges, but now I need to make those connections. Each one of these vertices gets connected. So the top vertices, the bottom right, and then the bottom left. So how many edges do I have? 1, 2, 3, 4, 5, 6, and then each of those vertices get connected. So 7, 8, 9. It's a systematic way to count all of these parts of our 3-dimensional figure. And then finally the faces. Since we have a triangle, it means from here, this edge here and this edge here are going to connect with a face. This edge here and this edge here will connect with the face. And then the bottom edge and the bottom edge will also connect with the face. So we have the 2 bases, 1, 2, and then we have the other 3 faces, 4, 5, 6. So 1, 2, 3, I'm sorry, only 5. 1, 2, 3, 4, 5. Okay. So hopefully this will help you when it comes to getting a perspective on what these parts are when we start to measure volume and area. Thank you, everyone.